So what we're looking at on the table in front of me here are a variety of different electrical components. So I'm going to use these components here to show you how to set up a simple circuit, talk a little bit about switches, and show you the difference between an open and a closed circuit. So first of all, here's our electrical source for this circuit I'm going to make here. We've got a 9-volt battery. 9-volt batteries have their terminals both on the top, the positive and the negative terminal. And so, what I'm going to use to help me create a circuit is this little doohickey here, this battery connector that just snaps into the top. It's helpful because then it just provides a wire in and a wire out. One thing to take note of during the video here is that color of wire actually makes no difference at all. Okay, maybe if I was showing you the quick bomb diffusion lesson, which I'm not, nor do I have any capability to do so, then sometimes the colors of wires matter, but here it doesn't. Okay, so there's our battery, and at the very least, all you need to complete a simple circuit is a battery, the wire connection, and the thing that wants the energy. So we've got two light bulbs here from some Christmas lights. So all we do is make sure we have wire to wire connection, or metal to metal in this case, and touch it to the top or the connectors, and you can see that both bulbs are lit, right? So at the very least, we just need the source of energy, the electrical load, so the light bulbs and the wire. Okay, we can make our circuits a little bit more organized or formal, though. We can add in wires. These here are different wires that I have. They are called alligator wires because they have little clippies that are like little alligator mouths. So they just clip on to the wires. So we'll get one on that and another one on this side here to connect in and out of the battery. Perfect. Okay, and then those wires are going to come around and connect to our light. And so once I connect this here, and even without clamping it on, just making that connection, we have a successful circuit running here. So we have the electrons that leave the negative terminal of the battery. They leave the negative terminal, they flow through the circuit, they flow through the lights, they give up their energy at the light, and then they flow back into the battery to get fueled up again. And those electrons are constantly in circuit, picking up energy at the battery, delivering their energy at the light bulb. All right, so there's our simple circuit. This time I'm just going to add in one additional component, and that is a switch to control the electron flow, right? In the circuits that I've shown you so far, the circuit connects immediately once I have connection between the wire. And so generally, we like to have something that's a little easier to control than having to disconnect the entire circuit. So here's a couple of different switches. There's many different ones that you would use. This one, obviously, you would recognize as what you would see as a light switch. This one here is just a button switch where you would push the button. So I'm going to connect one of those in. They connect the same way as any other electrical component in around the metal components. So I'm just going to get that snapped onto there. And one additional wire to complete that from the other side of the bulb. So we've got that. And connecting this back into our switch. Okay, so now I've got battery to switch to light bulbs back to battery. So I'll turn on the switch and you can see that those lights have gone on, right? And so it's controlled in that way. So I will turn that switch off and just show you can achieve obviously the same thing with a different type of switch. So there we go. And again, when I push down the button, we are completing the circuit. So, two terms that go along with this idea here is a closed circuit and an open circuit. A closed circuit refers to when the electrons are flowing, there is no break in the wire, and the electrons leave the battery, deliver their energy to the electrical load or the light bulb in this case, come back to the battery. Okay, so that's when the switch is on. When the switch is off, the switch provides an area to break the circuit or disconnect and prevent the wires from connecting and preventing the electrons from flowing. Okay, so when the switch is off, the circuit is open and the electrons do not flow through the circuit. Okay, so closed circuit on, open circuit off. Switches are sometimes referred to as circuit breakers. You may have heard of a circuit breaker before or a circuit breaker panel, something that you may have in your home as a safety feature. Sometimes, if you have too many things connected to a circuit or too many items plugged in at once, a a circuit breaker is there to or break or prevent or stop the circuit to prevent a fire or too much current when there's too much plugged in. Anyway, so there you go. Simple circuits with simple components. Again, these are just Christmas tree lights. This 9-volt battery, you may very well have things lying around your house or even electrical circuit kits, depending on what you've had, um, just as things or sciencey things you might have at home or gift sets you've had in the past. Anyway, if you have stuff, give it a go. And if you don't, that's fine too. You can see just what I've shown you in the video here.